Hello friends. So in the last lecture we have dealt with rank of matrix. So today we are going to start with linear equations. But before that, let's revise the rank of matrix. So what we are doing, we have to find the rank of this matrix. So how to find rank of this matrix? We will look at the first column and first element. It's a non-zero. So what we will try to do? We will try to make all the elements below it as 0. So how to make it as 0? We'll copy the first row as it is. Now, what about second row? We can do the operation R2 goes to R2 minus 2R1. That's 0, it will be 1, and that's 2 minus 2, again 0. Okay. Now, third row, it's a 3. So, how to make 3 as 0? 0, 1. R3 goes to R3 minus 3 times R1. So, see what will happen. This will be 0. 0 minus 0, it will be 0. Okay. Now, what will happen to 4? 4 minus 3, it will be 1. See, we have completed with row 1. Okay. Now we'll move to row 2. This is row 2. Okay. We have dealt with column 1. It's done. Now we'll go to column 2. Okay. Column 2, row 2. It's a non-zero element. Okay, so what we will do, we will try to make all the elements below it as 0. So it's already 0. So it's done already. So now we will move to row 3 and column 3. Okay, this is column 3, column 2 is done, and row 2 is also done. So we'll move to row 3, column 3. It's a non-zero element. So what we will do, we will try to make all the elements below it as 0. There is no element below it. So it's done. So what will the rank? Rank of A is this matrix A. So what will the rank? Rank will the number of non-zero rows. Count it 1, 2, and 3. So rank is 3. So you might be thinking why we are trying to read rank. So we will see the use of rank in linear equations. We also call it as row echelon form, row reduced form. Okay, so let's start with linear equations. We've all learned linear equations in different classes from class 10 to 12. So let's see the standard form of a linear equation. We can write a standard linear equation as a11 x1, a12 x2, a1n xn. It's a linear equation and variables. Okay, so there could be m number of equations. Okay, so we'll write all the equations like this: a21 x1, a22 x2, a2n xn. Okay, similarly the mth equation will be am1 x1, am2 x2, amn xn. This is C2, this is Cn. Okay, so what is a11? A11 is the coefficient, and what is x1? X1 is the variable. Okay, so aij is the coefficient. Okay, and xi is the variable. Okay. Okay. So let's try to represent this in matrix form. Okay. So this is a11 in matrix. What we can do? We can place a11 here. This is the a11 element. This is a12. Okay. Similarly, this will be a1n. Okay. This will be a21. Okay. This will be a31. Similarly, I'm erasing this. This will be am1. Okay. Similarly, this will be a22. This will be a32. Similarly, it will go to am2. Okay. Similarly, on this side, this is second row and nth element, nth column. This is third row, nth column. Similarly, this is mth row, nth column. Okay. So we can use the symbol A for this, for the coefficient matrix. Okay. Now these are variables. So let's see how to represent variables. So let's write variable as x, capital X. Okay. This will be x1, this will be x2, up to till xn. Okay. Now, what about the constants? We will represent it using the symbol B. This is C1, this is C2, all the way till Cm. Okay. This is A, this is X, this is B. So what we can write? The system as Ax is equal to B. You can see it, Ax is equal to B. A, X and B. So let's expand Ax is equal to B. See. Ax is equal to B. A was A11, A12, A1n. This is A21, A22, A2n. All the way till AM1, AM2, AMN. Okay. Now X, X1, X2, X3, Xn. This is C1, C2, C3 dot Cm. Okay. Now see, row 1 will go to this. Multiply row 1 with this. Matrix multiplication. A11 x1 plus A12 x2. Similarly A13 x3 all the way till A1n xn, and it is equal to C1. Okay, this is the matrix form. Okay, so we have dealt with matrix form. Okay, so what we will do, we will try to convert this matrix into row echelon form so that we can solve this equation. Okay, let's see how. But before that, let's learn some basic things. Okay, so there are two types of equation. One is homogeneous, the other is non-homogeneous. One is homogeneous, the second is non-homogeneous. So see, what's the difference between homogeneous and non-homogeneous? Suppose the B matrix is 0. Okay, like 2x1, 3x2, 4x3 is equal to 0. The right side is 0 in all the equations. Then it's a homogeneous equation. We can represent it as Ax is equal to 0. Okay. And if there is at least one non-zero on the B matrix, okay, if there is at least one non-zero element, then we can represent it as Ax is equal to B, because there are non-zero elements in B. Okay, so we will solve it in different way and solve this in a different way. For homogeneous equation, 0 is always a solution. See, suppose 2x1, x2 minus x3 is equal to 0. 0 will always satisfy this equation. Okay, try to put it as 0. Let's take x1 as 0, 2 into 0. Let's take x2 as 0 and x3 as also 0. What will it result in? It will result in a 0. So 0 is always a solution. But there can be an infinite solution to this or only a unique solution. If it has a unique solution, that is 0, 0, 0, we call it as trivial solution. If there are more than one solution, then we call it as infinite solutions. Okay, and when we come to non-homogeneous equation, it will have unique solution, no solution, or infinite solution. There will be no solution. There will be also a case of no solution. So we will deal with it in a separate class. Okay, so today we will deal with homogeneous equation. So let's see one more thing before starting with homogeneous equation. It's Rauche-Capelli theorem. Okay, so what's Rauche-Capelli theorem says? Suppose rank of A is not equal to rank of augmented A. I will tell you what is augmented A. Okay, A augment B. Okay, then it will have no solution. Okay, if rank of A is equal to rank of augmented A, okay, then it can has unique solution or infinite solution. Okay, so see, if there are n equations, okay, and n variables, A is in n cross n, okay, then there are n equations and also n variables. In that case, if rank of A is n, okay, then we call it as unique solution. Okay, and rank of A is less than n, then it's infinite solution. We will see it using example. Just remember this thing at least. Okay, now what is augmented A? We know linear equations can be represented using Ax is equal to B. So augmented A is written like this. We will write first the matrix A. We will represent it on the left side. Let's represent matrix on the left side. Okay, now after this you can give a straight line or you can give a dotted line, whichever you prefer. Okay, then write the matrix B, all the elements of matrix B on the right side. Let's copy C1, C2, Cm. Okay, this is augmented A. So why will we write this augmented A? We will deal with this on non-homogeneous equation. We will start with non-homogeneous equation, then we will see the use of this. But for the time being, at least remember how to write augmented A. Okay, because we don't want to deal with matrix A and matrix B differently at different times. We want to solve it simultaneously, so we use it like this. Okay, so let's start with homogeneous equation. Ax is equal to 0. Okay, it always has two types of solution, either trivial, that is unique solution, or infinite solution. Okay, so let's start with an example. We'll understand it using an example. So let's take equation x1 plus 2x2 minus x3 is equal to 0. I am taking an n cross n example, like n variables and n equations. Okay, we will also deal with m equations and n variables. This is a three variable equation, linear equation, three variables. So it's a homogeneous equation. First see, on the left side, on the right side, all as 0. Okay, the constants are 0. Okay, this is also 0, this is also 0, this is also 0. So it is of the form Ax is equal to 0. Okay, in this case we don't write augmented A, we will only deal with A. So what will be the A matrix? A will be 1, 2, minus 1, 2, minus 1, 3, 4, 0, 5. The coefficients of x1, 1, x2, 2, x3, minus 1. Okay. Similarly for row 2 and row 3. Now what is our x? X is x1, x2, x3. It is a 0 matrix. Okay. So this is Ax is equal to 0. Okay. So how to solve this? See. How to find the solution of x1, x2 and x3. Okay. So what we'll try to do? We'll try to find rank of A here. Okay. So let's find rank of A. See, column 1, row 1. It's a non-empty element. It has 1. Okay. So what we'll do? We'll try to make all the elements below it as 0 in column 1. So let's do it. We'll copy the row 1 as it is. Now column 1. See, R2 will be R2 goes to R2 minus 2R1. Okay. So this will be 0 and this is minus 5 and this will be 5. Okay. And what will be R3? R3 goes to R3 minus 4R1. Okay. Okay. Now, column 1 has a pivot element 1. Okay, we'll circle it so that we can understand it better. It already has a pivot element, non-zero element. Now we'll go to row 2. In row 2, we have already dealt with column 1, so we'll do with column 2. Okay, column 2, row 2. Now see, column 2, row 2 has a non-zero element. Okay, so what we will do? We will try to make all the elements below it as 0. Okay, it has minus 8. So how to make it as 0? What operation we can perform? See. So we can do it like this. Row 3 goes to row 3 minus 8 by 5 row 2. Okay, let's do it here. See, row 3 is 0 minus 8, 9. Okay, minus 8 by 5 times 0 minus 5 and 5. Okay, this will be 0 minus 8, 9 minus, let's take it inside, this will be 0, 8 by 5, 5, 5, this will be 8 minus 8 and this will be 8. Okay, let's solve this. This is already 0, it will also become 0 and this is 1. Okay, so we'll copy it here. Okay, so we have found the rank of the matrix. Okay, so see, what is the rank? Rank of A is 3. Okay, now what we will do next? See, we will replace this in the original equation, that is Ax is equal to 0. We will replace this matrix instead of A in Ax is equal to 0 to find the solution, because according to theorems, this and this are similar matrix. Okay, whatever operation we perform on Ax is equal to 0, that the same operations is equivalent to all the operations performed on the matrix A. We don't need to perform any operation on matrix X. Okay, so see, this is 1, 2, minus 1, 0, minus 5, 5. This is 0, this is 0, this is 1 into x1, x2, x3, this will be 0, 0, 0. Okay, let's expand this. Okay, now after expanding, what will be this times this? Okay, this will be x1 plus 2x2 minus x3 is equal to 0. Similarly, minus 5x2 plus 5x3 is equal to 0 and x3 is equal to 0. See, x3 is 0 in 3. Let's take it as 2, equation 2, and this is equation 1. Let's use equation 3 in equation 2. Using 3 in 2. Equation 3 in equation 2. What will happen? Minus 5x2 plus 5 into 0 will be 0. Okay. This is minus 5x2 is equal to 0. This implies x2 is equal to 0. x2 is also 0. x3 is also 0. Put x2, x3 here. x1 will also become 0. So what is the solution of this? x1 is equal to x2 is equal to x3 is equal to 0. That is trivial solution. Okay. So it has a trivial unique solution. Okay. So let's see another example where it will be infinite solution. So see, let's take another example. Okay, so here there are 3 equations but 4 variables. Okay, let's try to represent it in the form of x is equal to 0. Okay, so what will be a here? A will be 2, the coefficients. Okay, the coefficient matrix 2, 3, minus 1 and 1. Okay, this is of x1, this is x2, x3 and x4. The coefficients of x1, x2 and x3 and x4, we'll write it as like this. Okay. Okay. Now, from second equation, this is 1, this is minus 1 and this is also 1 and this is 0. Okay. From third equation, this is 5, 1, 3 and 4. Okay. This is the A matrix. What will the X matrix? X will be x1, x2, x3 and x4. Okay. And this is 0 matrix. Okay. This is a 3 cross 4. This is a 4 cross 1 and this is a 3 cross 1. Okay. Dimensionally it is also correct. 3 cross 4 cross 4 cross 1. Okay. This will be 3 cross 1. So let's try to solve this. Let's try to find rank of A. Okay. Or let's convert it into row echelon form. Okay. So row echelon form. So let's move to column 1 and row 1. See, it has a non-zero element. Okay. So we'll try to make all the elements below it as 0. We'll copy row 1 as it is. Now, with row 2, what we can do with row 2? Row 2 goes to row 2 minus half of R1. Okay. So what will happen? This will be 0. This is minus 5 by 2. This will be 3 by 2. And the last one, minus half. Okay. Row 3. Row 3 goes to minus 5 by 2 R1. Okay. So what will happen? This will become 0. Okay. This will be minus 13 by 2. And the last one will be 11 by 2. And this one will be 3 by 2. Okay. Now we have already dealt with column 1 and row 1. Okay. Now what we'll do, we'll move to row 2. Okay, and column 2. See, in row 2, in column 2, is there a non-zero element? Yeah, there is a non-zero element. So what we'll do, we'll try to make all the elements below it as 0. Okay. How to make it as 0? I'm writing this here in the top. Let's copy row 1 as it is and row 2 as it is. This is 2, this is 3, this is minus 1, this is 1. This is 0, this is minus 5 by 2, this is 3 by 2, and this is minus half. Okay. Now, how to make this as 0? We can perform an operation. R3 goes to R3 minus 13 by 5 R2. Okay. Now, let's perform the operation. This will be 0. Okay. What will happen to this? Look. This is 0. This is minus 13 by 2. This is 11 by 2. And this is 3 by 2. Minus 13 by 5 times 0, minus 5 by 2, 3 by 2, and minus half. Okay. Let's perform the operation. 0 minus 13 by 5 by 0. This is 0. Minus 13 by 2. And this is minus 13 by 5 into minus 5 by 2. 5 will cancel out 5. This will be plus 13 by 2. And this is minus 13 by 2. It will result in a 0. Okay. Now, what will happen to this? This is 11 by 2 minus 13 is 39, 39 by 10. This is 11 by 2 minus 39 by 10. Okay. This will become 55 by 10. 16 by 10. 16 by 10. That is 8 by 5. It will become 8 by 5. Okay. Now the last one. 3 by 2 minus 13 by 5 into minus 1 by 2. Okay. This minus minus will got plus. Okay. Let's multiply 5 here. 5 here. That is 15 plus 13, 28 by 10. Okay. This will be 14 by 5. Okay. Now, we have a pivot element here, a pivot element here. The next pivot element will be in row 3. Column 1 and column 2 are already done. So we'll move to column 3. So see, it also has a non-zero element. So it will be the third pivot element. Okay. Now we have already found the rank. What is rank of A? Rank of A is 3. See, 3 is less than 4. That is number of variables. Okay. So what I told you earlier, if rank of matrix is less than the number of variables, then always it will always have an infinite solution. So let's see how to write the solution. So we know these are pivot columns. Okay. So with pivot elements, the variable associated with pivot elements are always dependent variables. Okay. And non-pivot ones are independents. Okay. So let's write it as ax is equal to 0. Let's multiply with the x vector x1, x2, x3, x4. This will give us 0, 0, 0, 0, 0. 3 plus 4. Okay. Yeah. So let's expand these two equations. So first will be 2x1 plus 3x2 minus x3 plus x4 is equal to 0. The second one will be minus 5 by 2 x2 plus 3 by 2 x3 minus half x4 is equal to 0. Okay, this is equation 1. This is equation 2. Now the last one, 8 by 5 x3 plus 14 by 5 x4 is equal to 0. Okay, this is equation 4. Now see, in equation 4, what we can do in equation 4 is 8 by 5 x3 plus 14 by 5 x4 is equal to 0. Let's take 5 common, 2 by 5 common. Okay, so let's 2 by 5 common. This will be 4x3 plus 7x4 is equal to 0. Okay, we will take this on this side, then it will be 4x3 plus 7x4 is equal to 0. Okay, now I already told you the non-pivot ones are independents. Okay, we always try to represent dependent variables in terms of independent variables. Okay, so this is a independent variable and this one is dependent. This one is associated with x3 and this one is associated with x4. So x4 is always independent here. Okay, and x3 is dependent here. So what we can do, 4x3 is equal to minus 7x4. This implies x3 is minus 7x4 by 4. Okay, so what we can do, we can represent x3 in terms of x4. Okay, we found x3. Now what we'll do, we'll try to replace x3 and x4 here and find x2 in terms of x4. Okay, so let's write it here. Okay, so I wrote x3 here. Okay, and x4 is already independent. We have represented x3 in terms of x4. Now we'll try to find x2. Okay, so let's find x2. So we'll try to extract it using equation 2. Okay, because x2 is here, minus 5 by 2 x2 plus 3 by 2 x3 minus half x4 is equal to 0. Let's take 1 by 2 common from here. What will happen? Minus 5 x2 plus 3 x3 minus 1 minus x4 is equal to 0. We'll take 1 by 2 here. It will become 0 into 2, 0. So what we'll left with? We'll left with this. Okay. Now we already have the value of x3. Okay. Let's replace it here. Okay. Let's replace x3 with the value of x3, that is minus 7 by 4 x4. So what will become? Minus 5 x2 plus 3 into minus 7 by 4 x4 minus x4 is equal to 0. Okay. See what will happen to this. This will be minus 5 x2 minus 21 by 4 x4 minus x4 equal to 0. Let's simplify this. Okay, this will be minus 21 by 4 minus 1, that is, let's take LCM, minus 21 minus 4 by 4. This is minus 25 by 4. Okay, so what will be? Minus 25 by 4 x4. Okay, this is minus 5x2 minus 25 by 4 x4 is equal to 0. Okay, so see, we'll take x4 here, minus 5x2 is equal to 25 by 4 x4. Okay, let's cancel out 5. This will be 5. So x2 will be minus 5 by 4 x4. Okay, we got the value of x3, x2, and we already have x4. So what we'll do, we'll try to find the value of x1 now. Okay, so we already have equation 1 where we have x1, x2, x3 and x4. We'll try to replace the values of x2, x3 and x4 so that we can find x1 in terms of x4. Okay, so let's write the value of x2. x2 is minus 5 by 4 x4. Okay, so what is our equation 1? Equation is 1 is 2x1 plus 3x2 minus x3 plus x4 is equal to 0. Okay, let's replace the values of x2, x3 and x4 here. Okay, so it will be 2x1. What is the value of x2? Minus 5 by 4 x4. So this is minus 5 by 4 x4. Okay, what is x3? Minus 7 by 4 x4. This is minus 7 by 4 x4 plus x4 is equal to 0. Okay, let's take the LCM here. This will be 2x1 plus minus 15. This will be plus 7 and this will be plus 4 by 4 x4. Okay, this will be 0. Let's simplify this. 2x1 minus 15 plus 11. This will be minus 4 by 4 x4 is equal to 0. Okay, this is 2x1 minus x4 is equal to 0. This implies 2x1 is equal to x4. Okay, so x1 will be half of x4. x1 is half of x4. Okay, so we found the value of x1, x2 and x3 in terms of x4. Okay, so let's see how to write the solution now. We already found the values of x1, x2, x3 and x4. So see, let's see how to write the solution. So we write the solution as x1, x2, x3 and x4. Okay, so what is the value of x1? This is half of x4. Okay, what is x2? Minus 5 by 4 x4. What is x3? x3 is minus 7 by 4 x4. And x4 is as it is. Okay, and what was x1, x2, x3, x4? They are all real numbers. Okay, now see, this is x1, this is x2, this is x3, this is x4. So in all of this 4, what is common? See, x4 is common everywhere. Here. Let's take x4 common. So see, half minus 5 by 4 minus 7 by 4 1. Okay, for every x4 belonging to R, for all real numbers. Okay, x4 can be any real number. Okay, such that x4 can be any real number, such that if you put any value for x4, we will get the solution for all x1, x2, x3 and x4. Okay, so there will be infinite solution. So we say that there is infinite number of solutions. Okay, so this was homogeneous equation. In the next class, what we will start? We will start with non-homogeneous equation. So what is non-homogeneous equation? Where the right side is non-zero. This is not equal to 0. Okay, so we will start with non-homogeneous equation in the next lecture. Thank you for today. If you learned something valuable, please like, subscribe and share and comment also. Okay, you can also comment your doubts. Thank you.